the power to change this world, and therefore we use it wisely. Warm wishes on National Science Day celebration. Respected dignitaries, faculty members, and my dear students, a hearty welcome to this special lecture on the importance of science as a part of National Science Day celebration. I, Shruti Managers, Assistant Professor, Department of Mathematics, will be the host for the program. I request Ms. Shobana Thomas, Associate Professor, Dean of Science, to escort the dignitaries onto the stage. National Science Day is celebrated to commemorate the discovery of Raman effect by Nobel laureate Sivi Raman on this day in 1928. In 1986, the National Council for Science and Technology Communication asked the Government of India to designate February 28 as National Science Day, which the then government accepted and declared as National Science Day in 1986. The first National Science Day was celebrated on February 28, 1987. The event is now celebrated all over India in schools, colleges, universities, and other institutions. National Science Day is celebrated to spread a message about the importance of science used in the daily life of the people. It is celebrated to display all the activities, efforts, and achievements in the field of science for human welfare and to encourage the people as well as to popularize science and technology. The theme of National Science Day 2022 is Integrated Approach in Science and Technology for a Sustainable Future. As Albert Einstein said, the more I study science, the more I believe in God. To begin with, I now invite Ms. Sonia Jennifer, final year BSc student, to invoke God's blessings.
Bless the Lord, oh my soul, oh my soul. I worship your holy name. Sing like never before, oh my soul. I worship your holy name. You're rich in love and you're slow to anger. Your name is great and your heart is kind. For all your goodness I will keep on singing. 10,000 reasons for my heart to find. Bless the Lord, oh my soul, oh my soul. I worship your holy name. Sing like never before, oh my soul. I worship your holy name. I worship your holy name. I worship your holy name. Thank you.
Thank you, Sonia. Now I request Ms. Jeevita Saldana, Assistant Professor, Department of Botany, to welcome the gathering.
Good afternoon to one and all present here. Ask the right question and nature will open the door to her secrets, said Sir C.V. Raman. I deem it as my privilege to deliver the welcome address on this special day which is celebrated as National Science Day to commemorate the contributions of Sir C.V. Raman. It's my honor to welcome today's chief guest, Professor Ash Srinivasan, retired Director, UGC DAE Consortium, for Scientific Research, Indore, Madhya Pradesh, to this celebration. I welcome you, sir. I extend a cordial welcome to Reverend Father John Paul, Campus Administrator, and Reverend Father Julian, Assistant to the Rector, to the celebration. I extend a warm welcome to Mr. Vidyadhar Sanjay Nair, Vice Principal, to this event. A warm welcome to Professor D. Revana Siddhaya, Coordinator for National Science Day celebration. We welcome you, sir. Hearty welcome to Mrs. Shobana Thomas, Dean of Science, to this event. I take this opportunity to welcome teaching, non-teaching staff and students to this National Science Day celebration. Thank you.
Thank you, ma'am. I welcome you too to this program. As Isaac Asimov says, there is a single light of science, and to brighten it anywhere is to brighten it everywhere. I solicit the dignitaries to light the lamp. Professor from the Department of Physics, PG, to introduce the chief guest.
Dignitaries on and off the days, my colleagues and student friends. Good afternoon to one and all here. I feel extremely happy to present before you today's speaker, Professor R. Srinivasan. R. Srinivasan, sir, he is no new to us. He has been regularly coming to our college on various occasions. He's been part and parcel of this, every science activity that happens in our college. But then, once again, I tell that it is my privilege here to introduce him on this special day. Professor R. Srinivasan pursued his PhD in 1957 from Madras University and worked at IIT Madras. He was a Dean of Research and Dean of Student Welfare and Deputy Director. Prior to his retirement, he was the Director of UGC DAE Consortium for Scientific Research in Indore. His works span to larger domains of physics, so his basic interests are theoretical condensed matter physics, experimental low temperature physics. So mostly his works span around cryogenics, that is low temperature physics. So if in India we have a recognized cryogenic centers and research happening in cryogenics, I think sir is one of the pioneers to bring the subject live in India. his educational activities include, building the low temperature physics laboratories. Of course, whatever laboratories he has set across India, he has started from scratch. There was nothing meant for him ready, the plates were not served. He has started things from scratch, including the UGC DAE consortium. So it was all his effort. He has guided 24 students and they are awarded with PhD, and his publications are more than 250 in refereed journals. So you can see the amount of contribution that is given to the scientific world. So on this special occasion, I invite you, and I feel very thankful to the organizer in giving me a chance to introduce you, sir. So his memberships include the memberships of the International Cryogenic Engineering Committee. So he is the chairman for Program Advisory Committee in Cryogenics of DST for 10 years. So he is a member of Indian Academy of Sciences, fellow of the Instrumentation Society of India, and so on. The list is too long. With this, I would want to, put into your minds, the young minds, that you look at him, the energy that he has, the energy that flows out of him in, quenching the thirst to learn and teach science. At present, he is rendering his service in St. Philomena's College in our PG Department of Physics. He teaches course, he guides students for project. So his enthusiasm, I think we will all fail in front of. So once again, I thank the organizers for giving me an opportunity to introduce our chief guest, and I request you to take over, sir, to give your presentation. Thank you.
Distinguished members on the dais and friends, I would like to thank Professor Raman for inviting me to talk to you on this National Science Day. This day is to commemorate the discovery of Raman effect by Sivi Raman. He won the Nobel Prize in Physics in 1930. He was an indefatigable scientist with a tremendous enthusiasm for research in physics. His infectious enthusiasm motivated some of his distinguished colleagues to make seminal contributions to different areas of physics. Raman effect is an invaluable tool to the chemist for identifying molecules and the type of binding in them, and is used in chemical industries all over the world. Professor Raman continued his zest for physics research till the last breath of his life. The best way to pay a tribute to this great scientist, and I am now addressing myself to the students of science in this audience, the best way to pay a tribute to this great scientist is to follow your chosen area of science with the same devotion and enthusiasm that Professor Raman showed. Science has transformed society in the last 400 years. This National Science Day is also to acknowledge the tremendous transformative power of science. I am a physicist, and therefore I have a tendency to extol the contributions of physics. But Professor Raman reminded me during lunch that the audience will be a mixed one. And so I will curb this tendency and I will make some general observations on the importance of science and the limitations of science. While we recognize the importance, we must also recognize its limitations. I hope you like this talk. Anthropologists who deal with the evolution of the human species say that Homo sapiens, the species to which all of us belong, has existed on this earth for 200,000 years. I repeat, 200,000 years. This long period is divided into 3 ages. The Stone Age, which lasted for 190,000 years, followed by the Bronze Age, which started about 10,000 years ago, followed by the Iron Age, which started about 5,000 years ago and is continuing today. So you see, the Stone Age occupies 95% of this long period. And during this Stone Age, man lived as a hunter-gatherer. He will move in small groups from place to place to hunt wild animals and kill them for his food and gather tubers, fruits and for his sustenance, which grew widely for his sustenance. Somewhere, sometime during this long period, he discovered how to make fire. This was the first great technological discovery. He realized that fire provided warmth. He could cook his food with fire and he could bake clay to make it hard with fire. Towards the end of the Stone Age period, he even learnt to make the edges of the stones sharp because he used these stones for hunting. A blunt edge was of less use than a sharp edge in killing animals. This was development in technology. Around 10,000 years ago, agriculture started. Then man gave up his nomadic life. He realized that he could till the ground, sow the seeds, and reap the harvest of edible food grains year after year with certainty. So man settled in small agricultural communities near the side of rivers. When you stay in a place for a long time, you need a dwelling to protect you from the ravages of sun, wind and rain. He had to build houses, and he learned to build them with mud, grass and timber. he was producing grain, he had to store them. So he had to make vessels, he learned to make big mud pots. These are the developments of technology as it took place in the ancient days. Writing developed for the first time 5,000 years ago. There were three great civilizations at that time. The Indus Valley civilization, stretching from Mohenjo-daro in present-day Pakistan to western UP, Mesopotamia in the valley of the rivers Tigris and Euphrates, and Egyptian civilization on the banks of the river Nile. During these civilizations, man had already learned to extract copper from the ore and to make bronze by adding tin. So he substituted stone implements with bronze implements, bronze swords, bronze shields, bronze vessels. He learned to domesticate animals. The first mention of the wheel is in the Sumerian text, 5,000 years ago. So man learned to build carts with wheels drawn by domesticated cattle, using which he could transport goods from place to place. The potter's wheel was developed so that you can make pottery on the wheel. There was trade between the three civilizations. Material from one part, let us say Indus Valley, was transported to Mesopotamia through land routes by caravans. But occasionally goods were also transported by boat from the sea coast of Gujarat over the Arabian Sea and the Persian Gulf. That means man learned to build boats and to navigate boats. So this technological development continued till about 1600 AD with a very slow pace, because technology developed by accidental discoveries and by trial and error methods to find solutions. When the Iron Age developed, people learned to forge iron, make steel, and very good steel was made in South India called wood steel, and swords made of this steel were in great demand in Arabia and in European countries in 1200 AD. So I started with 200,000 years old when the human species Homo sapiens originated, and I have come to 1600 AD. During this period, technology did develop, but technological developments were very slow because they were made through accidental discovery and improvements were made by trial and error methods. So this development took place over millennia, thousands of years. You may now ask, were there scientific developments in the ancient days? And my emphatic answer is no. Sure, people speculated about the universe, about matter, about the sun, the stars, about spirit. For example, Leucippus and Democritus in Greece and Canada in India postulated or speculated that all matter was made of indivisible particles, which we now call as atoms. There were stray references in ancient Indian texts that the earth went round the sun and the sun attracted the earth. Did these speculations lead to the modern atomic theory of matter or the theory of gravitation as we know it today? No. Why? Certainly, speculation is the first stage in science. But if you don't go beyond the first stage, you are not engaged in serious science. And in ancient days, people speculated about many things, but they did not carry these speculations forward. Therefore, there was no development of science anywhere in the world till about 1600 AD, 400 years ago. Science started in the West with Galileo. It adopted a very rigorous methodology, and this was responsible for the rapid development of science in the West. What is this methodology? It consists of several stages. The first stage is very careful observation and recording of data over long periods of time of natural phenomena. As an example, Tycho Brahe observed the positions of the planets in the sky night after night after night for several decades. He produced a large volume of data about the position of planets and how they change with time. The second stage is you sift through the large amount of data and see whether there are some relations between the observed quantities. For example, Kepler sifted through the large amount of observations made by Brahe and realized that all planets move in ellipses around the sun, and he postulated 3 laws of motion. These laws are empirical laws, laws derived by experiment. Now walks in the theoretician with a mathematical bent of mind, trained in mathematical logic. He now makes a simple model of the system, makes some simple assumptions called hypotheses, and then uses mathematical logic to deduct consequences out of these hypotheses. If these consequences agree with the experimental laws, then the model is a good representation of the system. If the consequences don't agree with the laws, the model is discarded. Again, Newton postulated that any two particles attracted each other, and this attraction was proportional to the product of the masses and inversely proportional to the square of the distance. Therefore, the sun, which is a massive object attracted the planet, which was tiny, according to this law. And Newton worked out what will be the mathematical consequences of the law that he assumed, and found that the consequences led to Kepler's equations, laws of motion. So, the theory of gravitation he proposed gave a very simple model to the behavior of planets. But it doesn't stop there. Any two masses attract. Sun is very heavy, it is attracting the planet. It is providing the dominant force of attraction. But other planets also attract the Earth. They will also produce an attraction, and they will produce small changes in the orbit of the Earth around the Sun. These are called perturbations. You know what other planets exist, so you can calculate what are the small perturbations that will occur to the motion of the Earth around the Sun. And you find that the existing planets do not fully account for the perturbations. So you make a bold prediction. There must be other planets which have not been observed so far, and if scientists take the trouble of building more sensitive instruments and observe the sky, they will discover the planets. You can even say at what distance these unknown planets should be. And then the telescope was discovered, and people looked at the sky through the telescope, and they discovered the new planets Uranus and Neptune. And this added to the credibility of Newton's law of gravitation. But there was a drawback. Mercury is the planet closest to the Sun. Mercury moves around the Sun in an elliptical orbit, but the axes of the ellipse are not pointing in a fixed direction. They are slowly rotating, changing. This is called the motion of the perihelion of Mercury. Very slowly, but this was discovered through detailed observations. And this phenomenon could not be explained on Newton's ideas of absolute space, absolute time, and gravitation. This remained an unresolved problem for nearly more than 200 years till Einstein came. Einstein rejected Newton's ideas of absolute space, absolute time, space and time being two different entities. He said space and time form a joint four-dimensional manifold. He assumed that no particle can travel with a speed greater than light, worked out mathematically his theory of relativity on these hypotheses, special theory, and found it explained precisely the motion of the perihelion of Mercury. So what do the scientists do? They say the Newton's model is an approximation. A better model is Einstein's model, and we must adopt Einstein's model. Newton's model is rejected. So you see that science progresses by observation, by model building, theory, more refined observations, more refined theory, and this cycle of observations, theory and cycle and observations continue endlessly. No scientist worth his name will claim he knows everything about the universe. There is nothing further to discover. If you ask a scientist, he will say As far as I know, the present universe started 15.5 billion years ago in a big bang. The different galaxies are moving away from one another with velocities proportional to their distances. But if you make more careful observations, you may find that this model may have to be changed. And these observations have been made. People have found matter which does not emit electromagnetic radiation. This is called dark matter, and dark matter is 40% of the total quantity of matter in the universe. They also found that the universe is accelerating in its expansion due to an energy which is unknown called the dark energy, and the dark energy is 70% of the total energy. So now there is feverish activity to find out what is dark matter, what is dark energy. So you see, science progresses continuously. A scientist should never make a dogmatic statement. The second point is, once science developed, people understood how materials behaved, what is the constitution of materials, how you can change the properties of materials by changing the temperature, changing the composition, and so on. They could do directed research to improve technology. Originally, technology developed through accidental discovery, through trial and error processes. Now you can make directed research to improve technology. So technology improves very fast. This fast improvement of technology results in new instruments being developed with greater sensitivity, which the scientist, the experimental scientist, will use to make more precise observations. So science and technology have a very close symbiotic relationship. Technology can develop in the absence of science, but it will develop very, very slowly. But with science, technology develops very fast. Unfortunately, discoveries made in the laboratory which may have a potential for practical applications, this potential is not appreciated by the common man because he doesn't understand science. As an illustration of this, I will mention that Michael Faraday discovered the law of electromagnetic induction. He had a coil of wire, another coil of wire nearby. He passed a current through the first coil of wire, switched it off. So the current in the first coil changes from some value to 0. While it is changing, he observed in the second coil a voltage developing. This is called the electromagnetic induction. There was an exhibition in the Royal Institution where Faraday demonstrated this phenomenon. Sir Robert Peel, who was the Prime Minister of England at that time, he saw the demonstration, was not impressed. Okay, switch off something here, some needle deflect. So he was not impressed, and he asked Faraday, fine, but what use is your discovery? And Faraday replied to him, I don't know now, but I am sure that in years to come, you will tax the applications of this discovery. This was a very prescient observation of Faraday. because transformers are built on the basis of Faraday's law of induction, and transformers are extensively used for distributing electrical power from the generating stations to remote places. When electrical power became available in remote places, industries developed, employment was generated, new goods were made, and the government got revenue by taxing these goods. This is not understood generally. People think some discovery made in the lab is not of great importance. Well, I told you that science transformed society radically. How did it transform? I will give you some examples. First, taking the case of health care. There were scourges like typhoid, like smallpox, like cholera, which claimed many lives year after year before the advent of science. Once science developed, these scourges have been almost completely wiped out by planned vaccination and inoculation. New drugs and new antibiotics have been developed which have proved very effective against specific infections which could not be cured in the earlier days. Diagnostic techniques in medicine have improved greatly. Today, the doctor doesn't have to guess what is wrong with the patient. He can make an objective diagnosis of the illness of the patient and treat it. And healthcare has improved enormously all over the world. Then you come to agriculture. The use of chemical fertilizers, the use of machinery for tilling, sowing and harvesting have improved the agricultural yield enormously. We can now store food, we can transport food over long distances using deep freeze techniques. You come to transportation. The means of transportation before 1600 AD was either by riding a horse or by going in a chariot drawn by a horse. But today you can travel with high speed over rails, you can zip on the highways in automobiles, you can sail in a luxury liner on the seas, and you can fly through here at a speed of 500 kilometers per hour and reach New York within 24 hours. The change that has taken place in transportation is beyond belief. Communication. Putin declares a war against Ukraine, and within minutes, all over the world, people know that he has declared the war. This was not possible in the earlier days. You can see live the cricket match between Australia and England. Sitting in the comfort of your home, you can look at the TV and see the match live. You have a mobile. At the press of a button, you are able to contact a person who is halfway around the globe. Computers can store a large volume of data. You can retrieve the data in a jiffy. You can analyze the data very quickly. You can access information stored on computers all over the world through the internet. You can make offline payments. You can shop offline. You can register your documents, property documents. You can make online payments. You can make online transactions, financial transactions, and you can register your documents online with great speed. So you see, over the 400 years, the life has changed so much compared to the transformation that happened over several millennia before the development of science. That is the importance of science. No country can neglect science because of its tremendous power to change human life. Well, I have made you understand how important science is. Now let me spend a few minutes talking about the limitations of science. If you use antibiotics for the common cold, you are using an overkill, and this produces unwanted side effects in the patient. If you use fertilizers, chemical fertilizers, indiscriminately, ultimately the nutrients in the soil will get depleted and the yield will come down. If you use fossil fuels for automobiles, for industry, you increase the use of fossil fuels, they will produce harmful emissions which will cause lung infections. Carbon emissions will deplete the ozone around the earth. When ozone is depleted, ultraviolet rays from the sun will reach the earth. The earth will become warmer and warmer. Ice at the poles will melt. The level of water in the seas will rise and will submerge the coastlands. So what does it show? If you use science indiscriminately, thinking of the benefits that science has produced, there is a tendency to use science indiscriminately. If you do this, it is a recipe for disaster. Science is amoral. For example, science will tell you, you take a uranium atom, you break it, then you release a lot of energy. You can control the release of energy, and if you control it, you can produce useful power which you can use for starting new industries. It will also tell you how to control the release of energy. At the same time, science tells you that if the energy is released without control, there will be an explosion with devastating consequences. And it tells you how to make bombs which are more and more effective in causing devastation. It tells you both. So, the practitioner of science has to decide whether he will use science for doing good or for doing evil. Science does not give a moral sense. Science has no ethical value. There is nothing called right or wrong in the dictionary of science. These ethical values have to be learnt from humanities. Not only that, if you follow rigorously the method of logic, you become a machine, a thinking machine. And what happens to a thinking machine is illustrated by the following story. There was an ass, a very logical ass. It will always think very carefully and decide what it should do according to logic. Once it found itself tethered between two equally succulent bundles of hay at equal distance. So the ass was hungry. It had to start eating one of the bundles. But which bundle? So it appealed to logic. And logic could not find any reason why the ass should start eating one bundle of hay in preference to the other, because both were equally succulent, both were at the same distances, and the ass, being a follower of logic, starved. There is a human analog to this story. There was a gentleman called Peleg W. Ponder. As his name implies, he will ponder over every problem, apply reason and logic, and follow the solution suggested by logic. Once he was in the middle of a road with heavy traffic. He had to move to the right at the left side of the road, and he started pondering over the problem, which side should have moved according to logic. Both looked equally reasonable. And while he was pondering, a speeding lorry hit him and put an end to his dilemma. So this is what will happen if you go only by logic. I wouldn't like to be a thinking machine. I am a human being. I feel pain and pleasure, joy and sorrow. When a paper of mine, after long years of research, gets accepted for publication in a respected journal, I feel happy. When somebody passes disturbing comments about me, I feel angry. So, questions, feelings like kindness, generosity, gratitude, these have no place in the lexicon of science. These have to be learned from humanities through literature, drama, dance, art, music, and of course, sports. So humanities is as important as science. But however, looking at the tremendous change in human society brought about by science, we try to overemphasize the value of science. In many universities, humanities people are treated as second rate to science. This is wrong. Humanities is as important as science. Just as we celebrate National Science Day, we should celebrate a National Humanities Day. It could be on the birthday of Rabindranath Tagore, who was a great humanist. He wrote Gitanjali, which won the Nobel Prize. We must celebrate humanities as we celebrate science. So, in conclusion, my message to the students of science is, you should follow science with devotion, persistence, and zeal. At the same time, try to become a good human being by developing moral values, by developing interest in humanities. Read good literature, watch good plays, listen to good music, take part in sports, so that you will become a complete human being rather than a thinking machine. Thank you.
Thank you, sir, for giving us insight on the importance of science and also its limitation. Also the importance of humanity. I also thank Mr. Felon for introducing the guest. Now I request Reverend Father John Paul, the campus administrator, to give away the presidential address.
Good afternoon, everybody. Honorable Chief Guest, Professor R. Srinivasan, dear Sanjay Nair sir, and Professor D. Revana Siddhaya, and Miss Sobana Thomas, and all the teaching staffs and non-teaching staffs, and my dear students. At the outset, I wish you all a happy National Science Day. Happy National Science Day to you. So, as we are celebrating the National Science Day, we need to be rejoicing always. And at the end of the speech, as Sir also already mentioned, be a good human being, not a machine. Okay? We need to be a good human being. Science should encourage us and inculcate in us to be a good human being and to be helping others to be a good human being. Yes, Dr. Kuempu says such words in Kannada. Yenadaru agu, modalu manavanagu. Yes, we need to become a good human being. We are on the process of becoming a human being. This science should help us to be a good human being. Yes, dear friends, as we are celebrating the National Science Day, every year, February 28th, we celebrate this day as National Science Day. This day comes and goes, and we come and participate in the lectures or seminar or whatever that is workshop that is conducted, and we go back to our homes and live a normal life. That should not be. As we see the motto of our college, logo of our college, what is that? Caritas in Scientia. Yes, love through knowledge. Should always love the knowledge. And when you love the science will love you. Whatever the subjects that you are studying, you should love the subject whatever that you study. Without loving the subject, nothing will enter inside the mind. Though it may be difficult, sometimes we hear when the people say, what is the combination that we have taken? Arts. Oh, arts, leave it. Or science, oh, very intelligent guy this should be. That's what the mentality of the people. Yes, you should always grow higher and should love whatever the subject that you have selected, by it being arts or science or commerce, whatever the subject you have selected, you should love that subject. When you love the subject, the knowledge will automatically grow, and whatever that you study, that should not be a bookish. Whatever that you study should not be a bookish, but you should inculcate the knowledge. That knowledge should help you to be a good human being in the society and grow well educated people. And as we know, this National Science Day, the theme of this National Science Day is Science for People and People for Science. And we can also say Science for Students and Students for Science. Yes, if you are a lover of science, you should be loving the subject whatever that you study. And love through knowledge is the motto of our college. As the motto says, the knowledge should gain, as you gain the knowledge, that knowledge should be expressed through others through your love. Jnanadinda preeti edage. That's what we say in Kannada. We should gain the knowledge and start loving the other. And nowadays it is happening vice versa. That should not be. As to be a good human being, we gain the knowledge and you should start loving the other. And whatever the knowledge that we gain in our day-to-day life, in your day-to-day studies, and through whatever the means that you come across, that should help you to be a good citizens and to come up in life. And as the objectives of this National Science Day is to bring awareness to to people about the importance of science in our daily life and to encourage people popularizing the science and technology. Yes, every day as the Science Day brings with a new theme, and as this year we have a new theme, that is Science for People and People for Science. You should always grow in knowledge and wisdom. And as this, the purpose of this celebration is to give the importance in our daily life. Whatever that we come across in our daily life, that should help us to be scientifically reasoning out and going ahead. And it should help us for the welfare of the human being. And it should help us for the development of human being, and it should help us to grow in knowledge and wisdom. And at the outset, I already wished you Happy National Science Day. Once again, I wish that you grow in love and knowledge. May Sivi Raman, who always stood for science and got reward for physics, you also maybe grow in knowledge and in his path. May he inspire you as he has already inspired through his writings and through his research. And already, sir has already explained to you, I need not to go through the same. And you should always remember the same thing, and you should inculcate in your daily life and have a bright future. Thank you for your patience listening.
Thank you, Father, for your presidential remarks. Students, there is a sheet of paper which is being passed. Please write your name and a signature in that. As we wrap today's program of this special lecture, I request Dr. Asha MS, Assistant Professor and Head of the PG Department of Chemistry, to deliver vote of thanks.
Good afternoon, everyone. As we know, the celebration of National Science Day is to spread the message of science to the public. Respected dignitaries on the dais, teachers, and dear students, I feel honored and pleasure to get an opportunity to propose a vote of thanks on this occasion. I, on behalf of management, rector, vice rector, assistant to rector, principal, campus administrator, vice principal, PG director, IQAC coordinator, and entire fraternity of St. Philomena's College, convey my deep regards and hearty thanks to Professor Ash Srinivasan, retired director, UGC DAE Consortium for Scientific Research, Indore, our chief guest for gracing this occasion and sharing with us his knowledge on National Science Day. So, we are greatly encouraged by your gracious presence and immense benefited by your inspiring talk towards science. I request Campus Administrator, Reverend Father John Paul, to give vote of thanks to Professor Srinivasan. We are extremely grateful to our beloved Rector, Reverend Father Bernard Prakash Banis, for providing a stimulating environment for this occasion in absence. I wish to express our profuse thanks for giving encouragement and guidance to organize this program. I convey our thanks to Vice Rector, Reverend Father Maria Xavier, Principal Dr. Alphonsus De Souza, PG Director Professor Albert Pinto, and IQAC Coordinator Ronald Prakash Kutina for their support and wishes. Thank you. We are cherished to Assistant Rector Reverend Father Julian and Campus Administrator Reverend Father John Paul, for gracing this program. Thank you for that. We have today with us our most endearing Vice Principal, Professor Vidyadhar Sanjay Nair, who is known for his selfless commitment and mission of percolating education. I convey our thanks to Vice Principal for his support and gracing this program. Thank you for. The special thanks to Organizing Committee, Coordinator Professor Revana Siddhaya, PG Department of Physics, and Dean of Science Professor Shobana Thomas, UG Department of Physics, for gracing and making this program successful. Thank you, sir. Thank you, ma'am. Hearty thanks to member of Organizing Committee who worked shoulder to shoulder, and all of my colleagues to make this program successful. Thank you, everyone. We convey our thanks to all the UG and PG students for attentive presence. Thank you all. At the end, I once again thank all the distinguished assemblage in this auditorium for their amongst their presence us on this occasion. Thank you so much. Thank you.
Thank you, ma'am. Refreshment is being served to my right. I request everyone to have it. Thank you. Once again, this is to the notice of all the students. There is a paper being passed. Please write your name and sign in it. I thank all the technical staffs for your support to conduct this program successfully.